Okay, so this video is going to be about reading derivative graphs and also just reading function graphs in general. It's going to kind of bring up also the relationship between a graph of a function and a graph of its derivative. So the first thing I'm going to do is look at a graph of f of x. In this graph, there's a lot of special features. One of the features that we want to kind of look at and pinpoint is what we call the relative maximum and the relative minimum. So on this graph, it has one relative maximum. The relative maximum just means that it is higher than any point right around it. So if I were just to kind of look at and zoom in on points right around the point I've identified as the relative max, that point is higher than any point right near it. This graph also has one relative minimum, which is located down here. I've highlighted in yellow. I don't know if you can see that. So I'm going to change the color. So right here in orange, there's a relative minimum. This graph is a valley. It's lower than any point right around it. So this graph has a relative max. I'm just going to write this, a relative max at x equals 0 and a relative min at x equals 2. So the next feature we're going to kind of look at is what does the slope of this graph look like? What regions is this graph increasing or decreasing? So if you look from the relative max and everything before it, if I were to like trace this part of the graph. So this part of the graph, f is increasing. It's going up. One thing we know about when a graph is increasing is that when a graph is increasing, the slope is positive. So for what we know in calculus, this is really important. This means f prime is positive. The derivative is positive. And that's kind of what we want to associate with f increasing. We want to associate that f prime is going to be a positive number in that region. The same thing is true over in this section of the graph over here. So I can say the same pieces. F is increasing because the slope is positive, the graph's going up. F prime is positive in that region. And then in this middle region, the graph is decreasing. It's getting lower from left to right. So in this section, f is decreasing, which means the slope is negative, or in terms of calculus, f prime is negative. So that kind of sums up the features that deal with increasing and decreasing, relative max and min. And there's one more thing I want to point out, and it happens right here. That green dot that I pointed out is actually called a point of inflection. So at x equals 1, there's a point of inflection. That point of inflection happens when the graph changes concavity. It changes from opening downward to opening upward. So before the point of inflection, this graph is upside down. It's a sad face graph. It's concave down. After the point of inflection, the graph goes to being facing upward. So it's opening upward over here. It's a smiley face graph. It opens up like a cup. The other side is facing down like a frown. That's how I remember it. And when it's opening upward, we call that concave up. So those are kind of all the special features that help us sketch a curve. So now we're going to look at what this derivative graph looked like. So in this section, we have the derivative of the same graph that we just looked at, actually. So I kind of want to point out when we're looking at the graph of f prime, we're looking for different things. So if I go back to the graph we just looked at, in this first section all the way until x equaled 0, so in this blue section over here, what we saw was that we had a graph that was increasing and the slope was positive. When we look at f prime, we're just looking for where f prime is positive. And here's how we know a graph is positive. F prime is positive when the graph is above the x-axis. So if I were to show you, like, here's the x-axis, anytime the graph is above the x-axis, f prime is positive. Anytime the graph of f prime is below the x-axis, f prime is negative. So even though this graph might be decreasing, that's not helping me decide what's going on with the graph of f. So I'm going to put over here in this section, this whole section up to here, f prime is positive, Since f prime is positive, we know that f is increasing. And notice it happens until x equals 0. And if we go bounce back and forth, this graph was increasing. I highlighted it in blue until we got to that top point where x equals 0. So then in this bottom section down here, all the way from here, all the way to x equals 2, f prime is negative. So that means f is decreasing on that region. So f is decreasing until, or from, I'll say from x equals 0 to x equals 2. So on the interval from 0 to 2, f is decreasing because f prime was negative. And then we go back, and again, after 2, the derivative was positive again, so I could say f prime is positive. That means f is increasing from x equals 2 to infinity. I would write that as an interval from 2 to infinity, f is increasing. So what actually happens right when it crosses over? So right at 0 and at 2, f prime changed signs. And if we go back to the graph of f, we notice at 0 and at 2, we were looking at relative max and relative min. It's right here. So if I look at what's going on in this section, when f went from increasing to decreasing, we had a relative max. When f went from decreasing to increasing, we had a relative min. So when we're looking at a graph of f prime, that's going to change. When f prime goes from positive to negative, f has a relative max. So f prime went from being positive to negative, f has a relative max. When f prime goes from negative to positive, f has a relative min. So there was one more feature we talked about that dealt with the second derivative, and I will cover that more in concavity. I'll cover that more in the next video. I don't want to make this one too long, but I do want to show you these two graphs superimposed and kind of how I look at a number line for f prime. So in this specific scenario, what I have, I'm going to make this a little bit smaller. So what I have is a graph of f and f prime from the previous problem superimposed together. So I put them one right on top of the other just so you can see them together. So I'm going to look at just the graph of f prime mostly, and I'm going to point out the features again on f. So in this region, f prime was negative, which associates with this region up here where f decreased. In this region here, before 0, f prime was positive, which goes with the graph of f, where f is increasing. Same idea in this other region, we have f is increasing and f prime is positive. And if you notice where they change from red to blue, I have a relative max. When f prime goes from positive to negative, we got a relative max, and that's where the graph's at its highest point for f. And then when f prime goes from, be careful, do not say it. When f prime goes from negative to positive, which is right here at x equals 2, that's where the graph of f had a relative min, which also happened across the x-axis, but we have a relative min right here. One thing that's really nice to do is when you're looking at the graph of f prime, you kind of go through and say, okay, where is f prime 0? Because that's going to affect where f has some special features, relative max and mins. So f prime is 0 at 0 and at 2. So on a number line, I kind of write down like, okay, at 0 and 2, there's these things we call critical values. They're really special for the graph of f. And then I look at what's happening before 0. Oh, well, before 0, f prime was positive because it was above the x-axis. It was up here. When x got to 0, it changed, and now after 0, f prime is negative. And then right after 2, f prime went back and was positive again. So what I know about f I'm going to draw a little number line below it. Here's what F looks like in those regions. F increases, then decreases, then increases again, which is modeling what the shape of that graph was. And that's going to be it for this video. So make sure you took really careful notes because this is definitely going to be on the test in multiple questions.